In this recording, with the help of Cobb Douglas function, we will be able to derive what is the total cost function, what do you mean by an average cost function, and what do you mean by a marginal cost function. I've written these definitions here, but I'll be discussing them later. Let me just get to the point here. We have Q is equal to F of KL, which is root of KL. This is our production function. Okay, this is our production function, and our input cost vector is WR. W is the wage rate of labor and R is the rental rate of capital. Our objective is to minimize this cost, WL plus RK. I'm using L units of labor, so what is the total cost of labor? WL. I'm using K units of capital, and R is the rate of capital per unit of capital, so it is RK. So WL plus RK is the total cost which I have. Now my objective is to minimize this cost subject to the production which I have. So I have in mind certain level of production. I want to minimize cost in such a way that I'll be able to produce that level of production at the given input price vector. Our objective is now to minimize this cost subject to a given production function. Okay. So say for example, I want to produce Q equals to 40. Okay. I want to produce Q equals to 40, and I have the input costs of say 5 or whatever. Okay. Now, given these input costs and given the production which I want to attain, I want to find those cost minimizing input combination of K star and L star which will minimize my cost, and that is this entire exercise is going up to. My point is that I take you to derive the cost function. Your general cost function would be of the form where cost function is going to be dependent upon input prices, which are W and R, and the output Y. Okay. So what you do is that you find three partial derivatives: del L by del L, del L by del K, del L by del lambda. Fine. So del L by del L is W minus lambda root K upon 2 root L equals to 0. Del L by del K is equal to R minus lambda root L upon 2 root K. Del L by del lambda is Q minus root KL equals to 0. So in case if you divide first by second, what is it that you will be getting? You will be getting W by R is equal to lambda root K upon 2 root L divided by lambda root L upon 2 root K. Now simplifying this, your lambda will get cancelled out, 2 will get cancelled out, and once you simplify this, you will be getting W by R equals to your root K upon root L from here. Upon root L upon root K would make it to be root K upon root L, which will be just K by L. So W by R is K by L. Now, well, that would mean that K is equal to W by R L. You have to substitute this K equals to W by R L into the third derivative which you have found out, which is Q, which is equal to root KL. That is the third partial derivative which you have found out. But K is basically equal to W by R L into L. So this becomes root of W by R L square. Now L square will come out into W by R. Fine. But you've said this, that K is equal to W by R L, but you have found out the value for L, which is W by R L into root of W I'm sorry, so there's a mistake which I have done. So your L would be equal to Q root of R by root of W. Okay, so from here, let me just get away with this. Yeah, I'm so sorry. So it is W by R L. In place of L, you will write Q root of R upon root of W. Fine. So simplifying this, you'll be getting it as root of W upon root of R. Fine. So what you have got, and both of these are your K star and L star. These are your cost minimizing input choices. So K star is Q root of W by R, and what is your L star? Q root of R by W. This is your K star L star. But what is the total cost of labor? W into L star, so which is W into Q root of R by W, which is Q root of WR. Then what is the total cost of capital? It is R into K star. What is your K star? Q into root of W by root of R. Well, that would be equal to Q root of WR. So what is the total cost? Total cost is WL star plus RK star. This is your cost function. But in terms of this, your WL star is Q root of WR, while your RK star is Q root of WR. So you can say that your cost function is root of WR Q. So what you have found out, that your cost function is dependent upon W here. It is dependent upon W here. It is dependent upon R here. Okay, and it is dependent upon Q here. Okay, so it is root of WRQ. So this is your cost function. Now, cost function shows that for any set of input cost and output level, your input cost and output level, the minimum cost incurred by the firm is TC, and this is what you have found out. Your CWRQ. This is showing the minimum cost to produce a given level of Q with a given level of WR. Right? AC is the per unit cost of output. Okay. So for example, you have produced 100 units of output, and Q is equal to 100, and the cost of producing these 100 units is, say, $1,000 or something. So your average cost would be equal to 1,000 upon 100. This will be equal to 10. So it is cost per unit of output. So for every unit of output which you are producing, it is costing you 10. So since you are producing 100 units of output, it is costing you $1,000. MC is the change in the total cost for a change in the output produced. Fine. So 100 unit of output is costing $1,000, and 100th unit of output is costing, say, how much? 1012. Fine. So when you produce 101th unit, then your total cost has increased by 12 units, and this is your MC. Fine. And this you can also find out using the derivatives. Okay, that is the change in total cost with the change in Q. Fine. Now, given this function which you have found out, C equals to WRQ equals to C equals to root of WRQ. This is your total cost function. Fine. Now, if I want to find out C upon Q, this would be root of WRQ upon Q. So that would be just root of WR. And if I want to find out what is my C dash, which is DC by DQ, That will also come out to be root of WR. Fine? Okay, thanks.